So let's draw in our line again. We're going to be talking about the covalent bonds. You've got to have that stair step there. Remember, that's the dividing point. Covalent, that's when you share electrons. So keep in mind, you need to have a lot of electrons to be able to share electrons. The part of the chart that has a lot of the electrons, it's over here. This is the part that has a lot of electrons. These can also get in on it. So you're going to need to have like an element here, an element here, or you're going to need an element here or an element here. It's everything that's on this right side. It's something on the right side bonding with something else on the right side. And we can get these noble gases in on the action. It takes a bit of work though. So that's what we're talking about. We're talking about that one side of the chart. And remember, we aren't talking about charges anymore because our electrons are not being transferred. They're being shared. So there are no charges involved here. At least not on the elements. So a covalent bond, it occurs between a non-metal and so these are the non-metals, all of these are. The left side of it's the metals, so it's a non-metal and a non-metal. One or both atoms lend electrons. I'm going to use an E with a minus. They lend electrons, and those electrons are shared between the two atoms. You'll find this out in Chapter 5. There's this word called orbital overlap, and it just means that, remember, we learned that electrons are hanging out in these orbital spaces, and they're flying around really close. So if one electron's orbital space from one atom gets really close and starts to overlap with another's, they can jump into each other's space. That's kind of how you can think of it. So when that happens, and it happens a lot, the shared electrons that will make up the covalent bond. And we really think of this as a bond, not a positive-negative interaction. There is a certain distance between them that's the lowest energy, and that's what's perfect for the bond. This distance, it's unique to every atom. So if we're talking about a CH bond, the distance between those two atoms, it's completely different than the distance between like a carbon and a carbon atom. So it's unique. It's like a perfect distance. Again, you'll see about this in Chapter 5. So the atoms move to this distance, which is unique to each covalent bond, and it's called the bond distance. This is related to energy. That is in Chapter 9. Because when you do chemical reactions, you will try to break these bonds, or you will try to make them, and that costs energy money. Interestingly, both atoms will act as though the shared electrons are their own. So they both claim them, which is great. That's why this works. And it counts to their total count of valence electrons. If you forget what valence electrons are, they're the outermost electrons. And in the columns, in the tall columns, this has one valence electron, that has 2, 3, 4, 5, 6, 7, and 8. So there's the valence electrons, the outermost energy electrons. The motivation for the sharing, it's favorable to both atoms so that their valence electron count can reach an octet. Mentioned last chapter, octets were important, and they're going to come back with a vengeance this chapter. And of course, there are some exceptions you'll learn about. And so these are called molecules. And remember, 1 mole of a molecule is 6.022 times 10 to the 23rd. And again, we still call them molecules. Most covalent compounds are not soluble in water, and they do not conduct electricity in any state. And note that they have their own unique shape. Maybe I should say specific shape. They may combine into larger shapes, and with that, and with other molecules. Think of DNA. So if you zoom in on one little tiny part of a DNA, that's what we're talking about, is the little teeny tiny parts of it. But they will combine with others, and will have like either distance attractions, or they will have like long distance bonds. There's different reasons that it happens, DNA, proteins, things like that. So the second half of the chapter is going to be focusing on covalent bonding.